Hello, everyone, and welcome to the fifth in our series of Ask the Expert interviews on the Thermoscientific Orbitrap Exploris 120 mass spectrometer. My name is Maciej Bromirski. I'm the Senior Product Marketing Manager for the hybrid instruments. And today we are speaking with Olaf Scheibner, who is the team leader for sales support in EMEA on the subject of AcquireX intelligent data acquisition as an option for the Orbitrap Exploris 120 mass spectrometer. So hello, Olaf, and thank you for joining us today. And please start with your presentation.
Hello, Maciej. Thank you very much. Yeah, this is a quite intriguing piece of technology we have on this series of mass spectrometers. So what is AcquireX? And let's start with the point. So because we have a problem. The point is, if you want to do unknown data acquisition, non-target screening, we have a couple of options. But so one option is DAA, data independent acquisition, where you have all the fragments all the time. That's very good. But as you don't have precursor ion selection, you miss the direct link between the fragments you see in the spectrum and the precursor. So a direct structural determination is not possible. And in a situation of co-eluting compounds, only the most abundant will be shown. So you may have the right component being fragmented here, but there was a second one more important, more abundant. And then the library search will yield you with the result of this more abundant one, and you will not see the result for the component which you have in focus. And you know that the other one is co-eluted. So there are limitations to DAA, as much as versatile as it is. On the other hand, if you run top N MS2, which is the method of choice for many, you don't yield enough MS2 spectra because there are so many spectra to be triggered that no instrument in the world can really do that in the time given. So with one run, you get quite impressive numbers of MS2, but still you're not covering everything. And especially if you look into residue analysis as an example, where the abundances are very low, you will not capture them. But the good news is we have a solution for that. So what we want is to acquire more untargeted MS2 spectra, and we will use a recursive approach of sample injection. You can do this manually on AcquireX active systems, but you will spend a lot of time on that. It's quite tedious work. And so we fully automated this in the workflow called AcquireX. It's available on the Orbitrap IDX, and it's available on the Orbitrap Exploris for 80 and 240 as standard feature, and it is, as mentioned, an option on the Orbitrap Exploris 120. So the point is, if you want to do non-target screening or unknown data acquisition, you will need to inject a blank and find out what's in the blank in order to have to exclude background from the triggering. So you run the full MS, the blank and full MS, you create an exclusion list, you put that onto a list. Then you run the full MS, the sample full MS, and create another inclusion list. And so you have these two lists, and with these two lists, you go into the instrument method, edit this, and then you run the sample MS to the N. And you most likely need to repeat that because in one go, you will not have all the MS2 spectra covered. So you have sample injection, external data processing, list generation, method editing, and then single sample re-injection. That's the manual workflow, which is pretty tedious, which you can do on AcquireX Active, for example, but it will cost you a lot of time. And so in AcquireX, we've just put that all into one box. Basically, Excalibur, with the function of AcquireX, will do this all for you. But so what's the benefit of it? We have real-time component detection and real-time list generation. So what's in it for you? This is the following. You do an MS analysis, and this is the blank in this case, and you will find out the background ions. And the peak detection will not only find these blanks, but it will find adducts, for example, as well, because it doesn't make sense to trigger on the adduct. If you have the precursor, the M+H, it's enough to do that, and you can leave out any adducts because you have this information needed already. And so the system goes along, it excludes background ions, and then it goes along and triggers as many MS2 as it can, but then the run is over, and that's what you've got. But you can see here, there are still signals left. Then you go back again in a recursive manner, and you do the next. So you do number 4, number 5, number 6. Of course, per run, there are many more to be done, but in the end, you want to do 5,000 or 6,000 MS2. And this is not to be done in one run. And so we go this recursive way. And so in this iterative approach, we dig much deeper into the sample in terms of MS2 information. So this is how it looks in one scheme. You have the blank full MS and generation of exclusion list. You have the sample full MS, generation of inclusion list, and then a method with this exclusion and inclusion list is generated, and then the system goes iteratively 3, 4, 5, 6 times, as many times as needed, and as many time you have. So this is setting you set as the user, and tries to do as many MS2 spectra as possible from this inclusion list. So it's not given to chance anymore what is triggered, but we have done in these first 2 samples, and we have made sure that we know exactly what we want to do. And this task is then done in a sort of targeted manner so we don't miss anything anymore. So the outcome of this, and this is in the end the answer to the question, what's in for you? So you have the traditional data-dependent approach where you have certain recursive approaches, but you see the benefit of this is rather small. And in the end, you can get something like 30 to 40% of the precursors that are in your sample you get triggered. So you have the most abundant ones. And depending on the science you're in, you're looking into the less abundant ones, and this is all metrics you trigger, which is good to know, but not the game or the goal of your science. And so if you run AcquireX, you see we get way more done because we have excluded the background. We are really targeted into what we want to do after making up our mind with these 2 injections. So already the first injection is way more effective than in the other approach. And in the end, you get to a coverage of 70 to 80% of all precursors found in such a sample. And if you then do your science and you find out what's in for you, what's significant for you in that sample, then you even find that in the end of the masses that are significant for you in your science, you find MS2 coverage around 90%. So in one go, basically, that goes overnight, and you can go to sleep and just have a good time, and the MS is doing all the work for you next morning. You have in one go all the information you need. You don't need to re-inject. The samples may decay. You don't need to care about it anymore because you have all the information present already. In order to have your non-target screening as effective as possible with as little input from your side as you can even think of. So with AcquireX, the sample is coherent full scan only, even polarity switching, so you save time on that because you save numbers of injections. The MS2 spectra will be generated automatically from pool samples, and the data processing then is done in compound discover software, which is a little bit too much to cover today. So we will have another go in this series pointing out what compound discover software can do with this data for you. So with that, I thank you very much for your attention.
Thank you, Olaf. This was great. I really like the, your clear explanation of AcquireX and really the benefit for the user, which AcquireX brings. So again, this AcquireX data intelligent workflow is an option for the Orbitrap Exploris 120 mass spectrometer, but it's also a standard for IDX, Orbitrap Exploris 240 and 480. So with that, I also like to thank you again and the audience for tuning in and listening to this version of our presentation. And to learn more about the latest capabilities of the Orbitrap Exploris mass spectrometer, please visit our website at thermofisher.com/Orbitrap Exploris 120. And we look forward hosting you to the next meeting. So thank you and goodbye.